Welcome back, friends. In the previous session, we started our physical geography and we introduced about the earth. Now in today's session, we are going to continue with the crust as one among the layers in the internal structure of the earth. These notes, they are found in Msomi Bora, so you can go in the website of msomibora.com and then you can search for the notes of Form 3 Physical Geography. Now we are starting with the crust. Crust is the outermost and thinnest zone of the earth, which is found between 8 to 50 km or 5 to 30 miles. It is known as lithosphere. It is largely composed of igneous rock. Now, if you don't know about igneous rock, don't worry. We shall discuss about the categories of rocks. Now, igneous rock, they are always rocks which are very hard as compared with the other types of rocks. So igneous rock ni kama haya mawe unayoona ambayo ni magumu, they are igneous. Tenda kuona kwa mbele kuna sedimentary rocks na pia other types of rocks. Now, other types of rocks also exist as a result of changes on the earth's surface. So other types of rock, they result from the changes on the earth's surface. But the igneous rock, hizi ndizo ambazo zinakuwa kwa asili. Yale mawe ni kutoka uumbaji, they are there. So the igneous rock, they are there. But other types of rocks such as sedimentary, it's only because of the sedimentation of material. Sedimentary, imetokana sedimentation. Yani kwamba material yamesediment, yamekusanyika, yameform layers. Tutaenda kuona even the features of these three types of rocks and the rock cycle. Now, the rock are crystalline. Crystalline, that means ukisaga inakuwa kama crystal. Crystal ni chembe chembe. Hard, that means ni ngumu. And brittle. Because of being brittle, they tend to break when subjected to stress or forces, especially the compression force. So, tunasema brittle ni zile material ambazo labda kama ukigonga na nyundo inapasuka. So, the crust also consists of two layers, which are Sial and sima. Sial and sima. So in Sial, what do you have in Sial? Sial is the outermost layer of crust, which is rich in silica and aluminium minerals. Silica and aluminium minerals. The Sial of basis of continent. The Sial for the basis of continent. The presence of silica and aluminium minerals collectively form Sial layer. So you can see this name Sial comes from silica and aluminium. Silica and aluminium. The two names of minerals which form Sial, they form, or they are first two letters, they form the word Sial. So the word Sial is from silica and aluminium. From there we have sima. Sima is the layer which is found beneath the Sial. So Sial, let's say we have the earth's crust here, and if we have the earth's crust here, we can assume that this is the outermost land, and then from there, let's say we have a layer here. So let's say we have a layer here, and then after there, let's say we have another layer here. If all of this is the earth's crust, then this one will be Sial, made up of silica and aluminium. Beneath the Sial, we have the sima. So sima is below the Sial, and is made up of different minerals as compared with the Sial. So this is what is explained in this explanation. So we are saying that sima is the layer which is found beneath the Sial, below, beneath. It is the inner layer of the crust which separates from Sial layer by a zone called the coronary discontinuity line. It is very important for you to know these names because sometimes they come in MCQ. In your first questions of geography, maswali ya kuchagua ABCD, MCQs, multiple choice questions, you can be asked Conady discontinuity separates between, you must know, it separates the sima from sia. So it separates between sia and sima. Conady discontinuity line. The sima layer is composed of silica and magnesium. That's why it forms sima, silica and magnesium. So silica is present in both of these crust, but aluminium is present only in sia and magnesium is present in sima. So it forms the basis of ocean floor. Basis of ocean floor. This forms the basis of continent and this forms the basis of ocean floor. So what do we mean now? Let's say here we have the earth is crusty. If this is the earth is crusty and here the mainland, let's say. Here, let's say we have the ocean. So let's see in this part we have ocean filled with water. We have the ocean filled with water like this way. Now, as we have explained in our explanation, that the sea forms the basis of continent. That means when we are talking of the continent, we are talking of the mainland like this one. So if this diagram assumes that the structure of the earth, that means huku ni nchi kavu, then huku ni nini? Ni bahari. Huku ni bahari. So sia ambayo ni silica and aluminium zina form the basis of the continent. I hope unaweza kuwa unaona explanation ambazo tuli explain kwenye sia. We said about sia and we said sia for the basis of the continent. That means the basis of the mainland ambao hakuna maji. Then about the sima layer is composed of silica and magnesium. It forms the basis of the ocean floor. Base of the ocean floor is made of the sima layer. Now we are saying that sia and the sima layer together they form the crust. From there, let's move to mantle. Mantle, or sometimes it's called as mesosphere or mantle, which is found between the crust and the core. It lies beneath the crust. It is separated from crust by zone of separation called Mohorovic discontinuity. These are very important, or sometimes it is called as a moho in short, but the commonly used name is Mohorovic discontinuity. Very important for you to remember about this one, Mohorovic discontinuity. As I told you, these will normally come in your MCQ, that Mohorovic discontinuity separates between, or when you are explaining about the structure of the earth, about the crust, mantle and the core, you must mention this about the Conady discontinuity line, Mohorovic discontinuity and other things. So Mohorovic discontinuity separates between crust and mantle. It extends downward to about 2,900 kilometers. 900 kilometers or 1,800 miles, where the temperature may reach about 5,000 degrees Celsius. It consists of pale green minerals called olivine, or sometimes you can call them as ferromagnesium silicate, in the form of ultra-basic rock. Consists of lower and upper mantle. The upper mantle is rigid and crusty to form layer called lithosphere. So this is the mantle, and as we have said that mantle, it is divided into two layers, the upper and the lower mantle. Upper mantle is rigid and crusty to form large layer called lithosphere. The lower mantle is less rigid and form the molten layer within the Earth's interior called asthenosphere. Asthenosphere is the molten layer which is responsible for balancing movement of the Earth materials called isostatic readjustment. Balancing the movement of Earth's material which is called isostatic readjustment. Now when we are saying molten kitu kinakuwa kama uji mzito. That's what you can call as molten. So molten something inakuwa kama uji mzito. Or what you call as a molten. So a cyanosphere has been investigated, is found to be 100 to 200 kilometer below the upper surface of a cyanosphere. So that's the discussion about the asthenosphere. And as you can see, the temperature in the mantle is very high. So normally, no living organisms which are living in this part of the earth, because of the high temperature, which does not support the living cell to survive. Now from there, let's move to the third layer of the earth, which is the core. The core is the innermost zone of the internal structure of the earth. It is also called the baryosphere or centrosphere. It has a diameter of about 6,900 kilometers or 4,300 miles density of about. The core is also classified into two parts, the outer and the inner. It's separated from the mantle by zone of separation called Gutenberg discontinuity. Very important for you to remember. We started with Conrad, then we have discussed about it, Mohorovic, then now we are discussing about it, Gutenberg discontinuity. Very important for you to know. So Gutenberg discontinuity separates between mantle and the core. The Conrad separates between the Sial and the sima. Then Mohorovic separates between crust and mantle. Gutenberg separates between mantle and the core. Very important for you to remember. Now, again, the core is divided into the outer and the inner. The outer core, it is liquid in nature due to high temperature of about 3,700 degrees Celsius, and consists of nickel and iron. So because the symbol of iron is Fe, is Fe. So sometimes you can just summarize this by saying it is Nife, nickel and iron. It is estimated to be 2,100 kilometers with the density of about 10.5 grams per cc or per mils. So it's not important for you to know the details of these, or it's not important for you to know everything about these so as to answer your physical chemistry question in explaining the structure of the earth. But it's somehow important for you to know just the width, the kilometers, the height, the magnitude and the location, the discontinuity which separates the layers. They're very important for you to know. From there we have the inner core. It is thought to be solid in nature because of high pressure exerted from different parts towards the center. It is composed mainly by iron. The inner core is composed mainly by iron. It has a diameter of about 2,600 to 2,700 kilometers. Or in miles, it is 1,600 or 1,700 miles. This diagram is very important when you are explaining about the structure of the earth. If you explain about the structure of the earth and you don't draw a diagram like this, it will be very difficult for you to get the whole marks. That's why I told you in the first session that in physical geography we need to first grasp the concept and then go to diagrams. So this diagram, as you can see, here we have the crust. And from the crust, unaweza kuona tuna mainland. This is the mainland. As you can see, continents form. Biosphere consists of living and non-living organisms. And then here we have water. Hydrosphere. Hydrosphere, that means the part of the earth which consists of water. Hydrosphere. Biosphere consists of living organism. Living organism. But hydrosphere consists of water. Hydro is water. So as you can see here we have the hydrosphere, and this is the all living organisms which are living in water, all earth parties which are living in water. We have ocean, we have sea, we have lakes, we have rivers, and etc. But here in biosphere, we have continent form, where we have living and non-living organisms. This is the crust, and these are the external structure of the earth. But from here, we are going inside. We are going inside where we have the crust made up of silica and aluminium, which is the lithosphere. Inside of this crust, which is made up of silica and aluminium, other part of crust, they are made up of silica and magnesium, as how we discussed it. From there, we have this corner discontinuity. Corner discontinuity, as we said, that corner discontinuity tend to separate between the between the Sial and sima. We have the corner discontinuity. So you can see these labeling. Corner discontinuity is here. Then from there we'll have the mantle, and in the mantle, for example, here we have the mantle, and from the mantle there, the layer which separates the crust and the mantle, it is the Mohorovic discontinuity. As you can see, this black line is labeled as Mohorovic discontinuity. From the Mohorovic discontinuity, which is here, we'll have the mantle, and then the layer which separates the mantle and the core, it's the Gutenberg discontinuity. Gutenberg discontinuity. So as you can see, the core is made of nickel and iron, biosphere. Gutenberg discontinuity is there, which separates the mantle and the core. So that's what you need to know about the structure of the earth. In the next session, we'll be discussing about the external structure of the earth. Just continue to stay with me. Thank you.